So we're talking about piping, and piping used in HVAC. We have a lot of selections, and there are always new pipes and new ways to connect pipes. And we try to make the best out of it because, again, the labor cost, guys. The labor cost for plumbing is very expensive, and we want to make it as fast as possible. You really want to lose a lot of time connecting the pipes. Usually take around a week or so to lay out all the pipes, and it's better to use something that's easier and more convenient. However, you have to always double check and make sure you're within limits when it comes to pressure and when it comes to heat. So we talked about joining copper pipes. Usually we solder them. There are some that are threaded. Just make sure that it's the application for threading. There are also some fittings. So make sure you have all the fittings. Mostly you'll need a lot of 90 degrees fittings, and sometimes you might use 45. 90 degrees has the issue of a lot of pipe loss. So you lose 2 feet of friction from one small joint that's 90 degrees. Press fittings are very common. However, make sure if you use press fitting that they are rated for the temperature where the pipe will be operated. What is the temperature for the pipe usually? The water? 180. That's the general rule. Flat fitting usually are used for oil, not for water, but they can be used in water if you have the right compound, but I have seen them mostly for oil. Why does it work with oil? Does it work very well with water?
Water more thin.
Huh?
More thin.
Yeah, it's more thin, which means it's less viscous, so it can seep through it. So oil is very viscous, so it doesn't go through small little cracks like water. And also with water, it's going to be at high temperature, so it's more pressure buildup, and it's thinner. When things get like hotter, they get thinner. This is the piping schedule. So things we have to think about is temperature, pressure, and something that a lot of people neglect is the weight, and that's for support. And consider the weight also with the temperature. When things get hot, they get more malleable, and you might find some sagging. And we talked about piping for steam and how that was very critical. Like when you put pipe for steam and they don't have enough support, and if it's a long pipe, it might have a bulge, and you'll have settling water that will cause you to have hammering. Steel pipes are joined usually using thread, and steam pipes have different schedule and different rating. Usually they are dark color and they are carbon steel, and they last a long time, and they can withstand the pressure from the steam and the heat. We use OD for nominal because we are going to use threading to connect those pipes, and if you want to use threading, you want to have the right outside diamond, otherwise you're not going to be able to thread them. You can use Teflon tape in the joints. Nowadays they have paste that you can put in the pipe. Make sure it's rated for the right temperature, otherwise over time it will deteriorate and leak. For support, you want to place support between each 6 feet if the pipe is laid horizontal. If the pipe is vertical with not a lot of support, what will happen?
Sag.
It will sag, sometimes it could buckle, and it could also vibrate. I'm not going to go too much into vibration, but pipes do vibrate and cause a lot of noise. And we said that we want, for the proper system, we want the system to have the least amount of noise. If the pipe keeps cracking and making noise and banging, that's something very unpleasant for the, yeah.
How do you put support on a vertical pipe?
Good question. Let's say you have a wall, you have a pipe going through it, you'll have support next to the wall. They have support that can be next to the wall. If it's in the middle by itself, make sure it's the right thickness. That's why if you notice, if you go to somebody's basement and you see a pipe by itself, it's very thick and big, so it will not vibrate. If you put a thin pipe by itself, longer than 10 feet, eventually it will shake and vibrate, and you don't want that for your pipe. So make sure you place the pipe in the right place, near the wall. If it's by itself, make sure it's thick enough. Usually for sewer pipes, they're very thick, around 10 inches pipe, so they can act as its own support. Some thin pipes, if you have to put them by themselves, you can provide another pillar next to it to support it, otherwise it will bend. somebody can lean over it and he can bend it. So make sure you put the proper support. Did I answer your question?
Yeah.
Okay. So piping schedule and weight, schedule 40 and 80 are the most common that we use for plumbing or for heating systems, hydronics. PEX are very, very common. A lot of people brag about PEX and they're very convenient. You basically don't have to do a lot of threading. The connection is very easy. And if you see, it will be something similar to a control panel for electricity. And they even come color coded. So this is your hot water coming out, and this is your header coming out of the boiler. So each one of those pipes goes to a different zone or a different room, and it comes back cold. So you have your hot and neutral, similar to how you wire a system in parallel for electricity. They are very convenient when it comes to connection. And as you can see, you can bundle them together, put them in with some, what is it called? Not Ziploc.
Zip ties?
Zip ties. Put them with zip ties. It seems like a very inexpensive way to put it. However, people have reported that over a few years they tend to sag and lose durability, and some of them might leak around the joints. So make sure if you buy them, that rated at the right temperature, and get them from a reputable company. Because again, even though it's water leaks are very big, and it could be an issue. And there have been reports of them after leaking after a while, especially from the connections, but becoming very, very brittle. And they're easy to puncture, so make sure you put it in a place where nobody will put some hole. So make sure that the temperature is within rating and get the right warranty. I have not seen a lot of reputable companies using PEX for hydronic. Again, for lack of experience, they came up in the early 2000s, and we don't have them for a long time. Meanwhile, you can go to a house and see a system that's been there for 80 years. So we still don't have a lot of experience with them and how they react with the temperature. And again, we said before, what is one of the biggest enemies of hydrocarbon products or polymers? Plastics and rubbers.
It breaks you down.
Huh?
It'll break them down.
Yeah, how?
UV light.
UV. So you don't want to put these pipes in a place where it's a lot of exposure of sunlight. Because over time they will react to UV and they'll start to get brittle. And as a general rule, also if it makes a smell, that means that something is coming out of those pipes. They also react badly with glycol. So if you were to use antifreeze in your system, make sure that the system have the right pipes. From what I know, and from the pipe that they have in the market, most of these pipes react really badly with glycol. Glycol is a combination of alcohol and I think polyethylene solution, and they also mix water with it, and it's very corrosive. That's why when you use radiator fluid, they tell you to mix it 50-50 with the pipes. So make sure that those pipes are rated for glycol, or do not use glycol. Distribution, they're very easy for distribution, and they come with different conditions. And people who actually make PEX pipes, they have managed to give you a union between a lot of types of pipes to ensure good connection. So you can connect PEX pipes with steel, with copper, and also with PVC. So they have proper condition for all types of pipe that you might have in a house. However, I'm still skeptical in the conditions, and usually joints are where you expect to have most leaks. So make sure they are rated to the right temperature and you use the right compound. And again, most of the problems that happen in the beginning, they happen over time. So probably in a year or so, if you have to go and check on these pipes and make sure they're not even moist. Again, if you put pipes in a wall, there'll be an issue if it leaks, and it will be an issue also because you cannot see where the leak is coming from. So you have to go back and trace all those pipes. So in the project, when you do your your piping layout, if you have a floor plan. For example, and you will assume that you have a basement in the bottom, where the basement is not going to be looking this way. But if you have a boiler, this is your boiler. I want to see the layout of the pipe. So this is a one pipe system. You'll measure all the pipes and try to make it as realistic as possible. So, well, why would you need those symbols? Just to make the drawing more understandable for whoever is going to read those pipes. So you can highlight the elbows, 90 degrees elbows. Circulator will be here. Air separator, where would you have that? You'll have that here before the extension tank. This is my air separator here. What else would you need? Flow valve, probably expansion tank. You don't actually be very artistic with it, just like shows where everything is. T's, unions, zone valves, if you don't use zone valves. Where's the pressure valve? Check valve, you'll need a check valve, so you can put a check valve here. I don't see the pressure relief valve. But you know
Above
you'll.
the T?
Huh?
Is it above the T? All the way at the bottom, third one up?
This? I don't think so.
Check valve?
No, relief valve. Just put it in here and say pressure relief valve. So give me the rough schematics of what components you're going to use. And also as part of the project, I want you to go and see how much those things cost roughly. So you have an idea how much they cost, so you do not like get shocked when you go and you buy them. And you know how much in total the project will cost you in terms of material. And we're not going to worry too much about the labor and the details for the hour installation, at least the material. And if you notice, if you're going to go and price a installation for a boiler, the boiler, if you go from the warehouse, it's around like $2,000 to $3,000. But when you get a quote from a company, they will quote you around like $10,000 or $9,000, and that includes all these components and also installation. And get out to understand that the company also have insurance, which they pay for each job. So that 7,000 extra, it's has a lot included in it. So even though the material is not that expensive, there's a lot has to do with the installation. Plus, they're also liable for all the leaks or anything that happens to the system once it's installed. So, but at least you have an idea of how much things cost and how would you price a complete job. This table here is in your formula sheet, and basically it gives you how much heat will you be emitting from a pipe without insulation based on the size of the pipe. Why do we need to know this numbers? It's because if you have the piping in here, in this area, I would like to know how much heat I'm losing before I get to the room. And I have to decide whether I want to insulate that or leave it as is. So, why would I leave it as is? I might want some heat in the basement. Not a lot, but just a little bit. So that leak can be accounted for. And if you account for that leak, you might want to also add that to your heating load, whatever it is. So whatever bare pipe you're going to leave here after you do the piping layout, you might want to know how much is that leaking into the boiler room. So if, for example, the boiler is isolated in the room here, meaning that it's not a confined space. And what's a confined space?
50 cubic feet.
50 cubic feet. per 1,000 BTU. So if you have 30,000 size boiler, you make sure you want to have the right space. So for those who actually go and do a finished basement and they want to isolate the boiler, make sure that you are within limits for that volume. So anyways, if you have too much, if you have an isolated boiler here, and this is giving off too much heat from the pipe itself, and you go to the boiler room and it's very hot, you know that you're losing too much heat from the pipe. So you might want to think about the insulation. And this is the bare pipe, how much it's going to give off of heat. Okay? So insulation, when do we insulate and when do we decide not to insulate? So for these pipes, probably if it's really at the top, you might want to insulate it because all the heat's going to be at the top and it's not really that productive. So there are temperature limits for the insulation. A lot of insulation now is sold by per foot, and it's something you put as a sleeve on top of a pipe. And so this is a fiberglass, it's also fiber wool. Polyethylene is very useful. However, I don't think it will stand the temperature of the pipe. So make sure it's rated for these kind of pipes. There are two installations. There are some for cold pipes and some for hot pipes. The one we see for the compressor or the condenser outside, they have a sleeve made out of foam, and that foam is for refrigerant. It cannot stand temperature above 120 and 130. It might be okay for a couple of years, but then after that, it will start to slowly cook and become crispy and falls apart. Taping requirement, you cannot just use duct tape. Make sure you use the proper tape that can withstand the temperature. Moisture control. For some pipes, if you insulate a cold pipe, you might want to think about the moisture control, because what happens here, this pipe is cold, it will attract some moisture, and eventually the insulation will get down. And what happens to the insulation when it gets down? It will lose insulation power, it will grow mold, it will become an issue. Indoor-outdoor design is the insulation going to be placed indoor or outdoor. Combustibility, that is something very important, especially if you are going to insulate things near the boiler. And that's why you want to account for the stuff on the piping near the boiler. Is it going to be combustible? What if it gets some oil in it? What if it gets too hot? What if the relief valve does not work? So you have to decide whether you're going to insulate near the boiler or not. So again, you are not allowed to have any combustible materials within 5 feet of the boiler. Remember this, because I've seen a lot of people putting cardboard or plywood around the boiler. So per code, it has to be within 5 feet. Of course, once you get the license for the boiler and the installation, you can do whatever you want later on. However, if you have to go through insurance, or if there's any issue, probably somebody will come and investigate and realize that you actually violated the code by putting combustible material next to the boiler. So, freeze protection. That is a very, very, very big issue, and it's very important because we face a lot of problems during January and February when the temperature drops and becomes really cold, and suddenly we have a pipe freeze. Once pipe freeze, they will burst, and that is a very expensive repair because once it bursts, it's going to leak, and you're going to go and find the leak, and depending on how big is the leak, it will dictate how big of a job you have. So for antifreeze, we use 50-50 or up to 60% of glycol and water. You cannot use only glycol because we said glycol can be corrosive and also have different thermal properties. Are we going to decide to have antifreeze in the system the entire year, or is something we're going to add only in the winter and take out? So antifreeze has lower thermal capacity than water, which means that it will not carry as much heat, so you might have to increase the temperature inside the boiler. So let me write this down. That means have to increase boiler temperature. Increase pump GPM. So if you suddenly change to antifreeze and you realize that the house is not heating properly, you know this is the reason. The properties of the antifreeze is different, and antifreeze has the possibility of forming sludge. It has some chemicals that will react with water and heat, and over time it will cause it to have some sludge. That's why you have to flush your system once a year, or at least get rid of the oil accumulation. In your car, probably if you look at the repair manual or maintenance manual, they'll tell you to flush your system once every 3 years, at least.
What, the coolant?
Yeah,
It's like once a year.
once a year. I've seen once every 2 years or 3 years, depending on what kind of coolant you have. If you don't, huh?
Car will probably rot out before it
Yeah. So that's the reason you have to flush it, and a lot of people do not do that, and eventually you will accumulate a lot of sludge in your water jacket, inside the motor, inside your radiator. So it has to be flushed periodically, and if you look at your radiator, there's a drain where you drain all the coolant and put a new one. And in the car engine, again, you never use pure water, just water, because it will freeze and burst your radiator. So water is less likely to cause sludge than glycol. Glycol does, but again, it has a lot of properties that we would like to have in the system. Reaction with material, glycol also does have bad reaction with steel and sometimes with copper. So again, that's why we limit that to 50-50 or 60%. Expansion tank. So the calculation for the expansion tank will be different. Glycol expands. Yeah.
I can't wrap my mind around how 50, 60%.
So you can go up to 60%. That's the maximum. But the most common one is 50-50. 50% glycol and 50% water.
Right, so that would be 50%.
Yeah, but you can also go to 60. That's the maximum limit.
60-40.
So it's going to be 60-40.
Okay, so, alright, I got it.
Got it? The expansion tank will change in size, not dramatically, and that's why we have the calculation. If you decide to switch to glycol, you might have to have a bigger expansion tank, because antifreeze expands faster than water, it has different properties, so you might want to make sure that you have the right size expansion tank, otherwise you'll have a leak of antifreeze. If you switch from water to antifreeze without doing any of the precautions, you might have some leaks. It's not a big deal. However, if you leak some antifreeze, it will be a big deal if you have pets. Yeah, drink it. They love it. They love
Sweet.
antifreeze. So it's sweet for them, and it's poisonous and toxic, and they will die. Also, it's toxic and poisonous for human. So it's not something. Actually, if you have kids around, you don't want to be having a lot of leak of antifreeze, especially inside the house. And what does it smell like if you burn it?
You said it smells like sugar burning.
Yeah,
You know,
it smells like maple syrup a little bit.
It's maple syrup.
So if you leak some antifreeze and you smell it in the house, you know there's something, a little leak somewhere. Pumping power has to be changed. Increase or decrease. It's going to be increasing because glycol is lighter than water and requires more pumping power to compensate for the loss of heat capacity. Other methods we can use to prevent freezing is keeping the water running the whole time. Whether it's, so you can reprogram your aquastat to keep circulating water all the time, only during that season. Like that will lead to more power consumption. So keeping the water running is another good way to prevent the water from freezing. Sometimes they say you can open the faucet a little bit, make it drip, not drip, like more of like a small line, so the water will keep circulating and prevent the freezing. If you don't allow the water molecule to settle, it will not accumulate and it will not like start to form crystals and ice. It will not start to ice. And also, if you notice, usually ice formation happens in around the molecule, around a solid, so you need some kind of dust and debris to form a molecule of ice. So you always want the system to be clean. So flushing the system also help reduce the possibility of having frozen pipe. Drain the system, that's another way. If you're going on vacation, or if you don't want to heat the house in the winter, you can drain the entire system. And if you notice, there's a lot of pipes where they have a lot of gate valves or ball valves where they have a button, so you can press it and it will drain all the water from the pipe. So let's say you have a third floor that you're not going to use in the winter, an attic floor, and you had a bathroom there. You make sure that you drain all the water from those pipes. So that's another way to prevent from freezing. System cleaning also, if the system does not have a lot of debris, it's most likely it's not going to freeze as fast. Also monitor the water level. If you have more water, the right amount of water, that will be easier. That'll be harder for the water to freeze. And if you have bubbles in there, bubbles can form cold pockets. Those cold pockets can be the first part to freeze in the system. So these are some of the methods you can use for anti-freezing. In summary, so pay attention to the pressure type and temperature for the pipes. Design for proper pipe support, and consider the heat aspect, that it's when it gets high it's going to be softer, and provide the proper support when you have the pipe horizontally or vertically. Try to have consistent pipe size. Why is that? Like if you're going to use 3/4 in a residential house, you might want to stick with 3/4. Why?
Pressure.
Maintaining the right pressure. Also, I don't want to go into too much into fluid dynamics, but when you have an expansion or contraction, the pipe will start to swirl and you have some kind of turbulences and eddies and vortices. So the pipe, a certain expansion, you'll have some kind of vortices in here, and those vortices will cause you to have cavitation and bubbles, especially if you did not account for those. Also, at these edges, when you expand, you'll have a lot of accumulation. You'll have a stagnation point, probably on the top and the bottom. You have a lot of stagnation points where whatever debris you have, it will settle in there. That's why when you see an expansion for like steam pipes, if you look at steam pipe, usually they do special expansion where the pipe will expand only in the top, not at the bottom. Those for steam. So you want the flow to be going one way, it will expand. Again, steam is gaseous, so it will expand and you don't have any accumulation in the bottom. So always think of the accumulation, because again, it will deposit whatever debris you have in that little crevice in there, and over time it will start to clog. Most problem with the system happens when it's dormant. If the system is just sitting doing nothing, probably that's when you have a lot of issues, and the pump will start to accumulate sludge. And probably you have the same issue with your car. If you have a car sitting in the garage for 6 months, when you turn it on, you'll find a lot of issues with it. It's going to be vibrating a little bit, the tires might be like a little bit saggy, and if you visited some big power plants, they always try to turn it in an idle mode, so at low speed, but keep it running instead of having mothball. Check local codes for proper connections. Make sure that the connections are suitable for either oil or steam. And in the CMR, when we install oil burner, they ask you to use only flare joints for oil, but they have different codes for other things as well. Okay, do you have any questions about pipe and pipe sizing? So for the project, let's all stick with 3/4 because we're using residential. That will make things easier. I hope one of the group members will be an artist and try to sketch the whole thing as a layout and tell me what pipe to use. try to make it as realistic as possible. Again, this project is not going to see the light, it's not going to be materialized, but at least you have an idea. Okay?